Hello, welcome back learners to the channel Unified Learning. In this video, we'll be continuing with carbon and its compounds, class 10th chemistry, explanation according to the 2021 syllabus, as according to the deleted syllabus by CBSE. Moving to the occurrence of the carbon. So, where it is found, it is present in the fuels like wood, charcoal, coke, petroleum, natural gas. And carbon also exists as in state that is free state. For example, graphite, diamond, and fullerenes. We'll talk about it in more detail as well. Okay, learners. So moving further with the electronic configuration of the carbon. So atomic number is 6, as you already know that, and electronic configuration is K. K shell is having 2 electrons, L shell is having 4 electrons. Moving further with the covalency. So covalency of carbon is 4 only. As moving further with the nature of the carbon. So nature of compounds formed by carbon. As carbon forms covalent bonds with different atoms because of the two reasons. That is because that carbon cannot lose its 4 electrons in the as it is present in the outermost shell. that अभी आपने देखा कि L shell में 4 electrons हैं. अगर वो उन्हें लूज करने का सोचेगा तो उसे इतनी ज्यादा एनर्जी चाहिए जो उसके पास नहीं है. And if it wants to hold any 4 other electrons from any other atom, so it's also difficult for carbon because to hold that extra electrons, it is difficult for the carbon. Moving further with the versatile nature of the carbon. So versatile nature of the carbon says that carbon is very much adaptable. If we say that it cannot lose or it cannot gain any electron, but yes, if we say that it shows catenation, that is which forms covalent bonds with other carbon atoms and to form longer chains of structures. We'll talk about it like diamond, graphite, and fullerenes also. Okay, so this is the reason for the presence of vast number of organic compounds in the nature. Moving further, let's talk about the tetravalency. So having a valency of 4, carbon atom is capable of bonding with atoms of oxygen, hydrogen, chlorine, and other elements also. So it requires 4 electrons. So that is why it's said to be tetravalent. I hope it is clear. Tetravalent means that it requires 4 electrons to make any covalent bond. So tetravalent, okay. The smaller the size of carbon atom enables the nucleus. So कार्बन का जो साइज है वो छोटा है. So इस वजह से जो उसका न्यूक्लियस है वो एटम्स में जब इलेक्ट्रॉन्स शेयर होते हैं तो वो उनको स्ट्रांगली होल्ड कर लेता है. Okay, moving further with the allotropes. So allotropes is basically if we say that allotropes are the various physical forms of an element. For example, the crystalline forms are diamond and graphite, and whereas amorphous form are charcoal, lamp, coke, and carbon gas also. Moving further with the diamond. Okay, so diamond is a 3-dimensional network, strong carbon-carbon covalent bonds. Due to that, it is hard in nature with high melting point. As you can see the structure also, that it is too much tight and मतलब बहुत ज़्यादा ही close है एक तरीके से, ठीक है. Each carbon atom is bonded to 4 other carbon atoms, as it is very much clearly visible in the structure that 4 atoms के साथ कार्बन क्या है, joint है, ठीक है. It is bonded. Okay, it shines in the presence of light. It is a transparent solid. Okay, it is a bad conductor of electricity because there is no free atom. As you can see the uses here as well. Graphite. Graphite is, if we talk about the graphite, so graphite has a metallic luster, soft and greasy to touch, and as well as it is a big covalent structure with each carbon atom joined with three other carbon atoms. वहां पर कितने थे? हमने देखा वहां पर 4 से ज्वाइंट था, लेकिन यहाँ पर कितने से ज्वाइंट है? 3 से ज्वाइंट है. प्लीज कीप इन माइंड ग्रेफाइट और डायमंड में क्या क्या डिफरेंसेस आ रहे हैं. ठीक है, हेक्सागोनल स्ट्रक्चर है. प्लीज सी द स्ट्रक्चर केयरफुली. यू कैन सी द हेक्सागोनल स्ट्रक्चर joined with three other carbon atoms. This is very much clearly visible to you in the structure. And layers have weak forces, so please notice that the layers have weak forces. They are not too much closely as in the diamond. जितना hard था वो hard क्यों था? Because carbon बहुत ज़्यादा ही closely joined थे, closely bonded थे. But in graphite it's very weak forces. That's why यहाँ पे layers slip कर जाती हैं. Okay, so you can see the use also used as pencil lead and as lubricants also. Fullerenes. So fullerenes, this is the structure of Buckminster C60. Okay, and this looks like a cage-like structure. That is a spherical molecule. Moving further, that C60 molecule is a symmetrical made structure. Please see the structure carefully. You can see that this is very much symmetrical. If we talk about the diamond and the graphite also, just too much, very much symmetrical, very different structure from other two we have talked about. Okay, moving further, as it is fused ring of aromatic system. So aromatic system means that it is too much closely and too much tightly, too much strong bonds are there. 20 hexagons and 12 pentagons of C atoms. So you can see that there are some hexagons and there are some pentagons as well. Okay, please notice the structure, how it is made. Okay, and saucer ball shaped भी बोलते हैं इसको, बाकी ball भी कहते हैं. Okay, and fullerenes looks different from the diamond and graphite. Try to recall. I will just show it to you. Like, see the structure of diamond, then the graphite, and then the Buckminster. So it's too much different from all the other two. Okay, it is a yellow powdery substance, as we have just talked about the graphite and diamond. So C60 molecule is a yellow powdery substance, and it just dissolves and turns pink. Turns pink when you dissolve it into the toluene. Okay, moving further with the covalent bonds. So covalent bonds are basically, if we say that it is a covalent bond is a chemical bond in which pairs of electrons are shared between two atoms. So to understand it in more easier way, we will understand it with the help of electron dot structure. Formation of hydrogen molecule. So let's understand how hydrogen molecule is formed. So atomic number of hydrogen is 1 and valence electron is also 1. So as you can see that we have taken two hydrogen molecules, and this is how the bond is formed. Moving further with the formation of the CH4 molecule. So atomic number of carbon is 6, so valence electron is 4. And atomic number of hydrogen is 1, valence electron is 1. Already talked. Okay, so how they are forming the molecule? We have one C carbon atom, and that is we can just say that we have one carbon atom and 4 hydrogen molecules, one carbon molecule and one hydrogen molecules, and this is how it is forming the CH4 molecule, which is also known as methane. Okay, moving further with the CO2 molecule formation. So again, carbon is having 6 atomic number and valence electrons 4. Atomic number of oxygen is 8 and the valence electron is 6. So here we are taking one carbon atom and 2 oxygen atom, and the molecule which is formed, as you can see that it is clearly visible to you that it's forming a double bond here as well. Okay, moving further with the H2S molecule. So here we have sulfur. Sulfur has atomic number of 16 and valence electron 6, and already talked about too much that hydrogen is having atomic number 1, valence electron 1. So here we are taking 2 hydrogen electrons Okay, so here we are taking 2 hydrogens molecules and 1 sulfur. Okay, and this is how the molecule is formed. Moving further with the bonding of oxygen. So as you know that the uh, oxygen exists as O2 molecule. So oxygen is having uh, atomic number 8, and if we talk about its L shell is having 6 electrons. So you can see that here is the double bond present, right? So for double bond we can say that there are 2 parallel lines. Already clear to you? What are 2 parallel lines? Already clear, I hope so, as you are studying since 6th class, right? So parallel lines. So each atom of oxygen shares 2 electrons with other atom to attain the nearest noble gas configuration. Are you getting it? So दो ऑक्सीजन के एटम्स अपने 2 इलेक्ट्रॉन्स को शेयर करेंगे to attain the nearest noble gas configuration. Okay, so the shared pair of electrons between the oxygen atoms constitutes a double bond. As you can see that here is the double bond present, and as well as if we say that that it is a 2 parallel lines also, right? So that is how it exists as O2 molecule. Moving further with the bonding in the nitrogen. So nitrogen is having atomic number 7 and 5 electrons in its outermost shell. So this forms a triple bond. The picture is not clear, I think so, but yes, you can see that they have the triple bond is forming, and so each atom of nitrogen shares 3 electrons with other atom of nitrogen to attain the noble gas configuration. This is very important, that why they are sharing. So why they are sharing to attain the nearest noble gas configuration. This is very important to understand. Moving further, the shared pair of electrons between the nitrogen constitutes a triple bond. So here the triple bond will be formed, and as well as the 3 parallel lines. So that is how the nitrogen exists as N2 molecule. I hope it is clear to you. Moving further with the carbon compounds on the basis of structure. So there are 2 structures, straight chain and the branch chain. Straight chain, as you can see, the carbon is in a straight chain, and in the branch chain it can move a little bottom of the C and little below of the C. So yes, so here is the branch. Okay, if we can see that there is one more carbon on the other as well. Moving further, I will tell you that how we are using it in the further topics. So let's talk about the isomerism before understanding the structures. Okay, so compounds having the same molecular formula but different structural formula and properties are known as isomers, and this phenomenon is known as isomerism. So what is structural isomers? So that is the important part, that is we are going to study further. Okay, so compounds having the same molecular formula but different structures are called structural isomers. So to understand this, we can just say that for example, we have isomers of C4H10. Okay, so as you can see that is N-butane, but here we can see that this is the straight chain, got it, and this is the branch chain. Clear to you? इतना समझ आया that structure chain and straight chain and branch chain कौन सी है? इसके बाद इसको समझते हैं. This is the isomers. So that's why iso is written here. So isomer of butane is this one. Okay, moving further with the isomer of pentane. So the basic formula is C5H12. So here we can see that N-pentane, this is a straight chain, but these both are the branch chain. That's very right. These both are the branch chain. Yes, so this is the isopentane and this is the neopentane. So let's moving further with the hexane, isomers of hexane. So the basic formula that is C6H14, and this is the straight chain, straight chain structure, and this is the branch chain structure. Here we have three isomers of the hexane, I'm sorry. So that is 2-methyl pentane, that is isohexane, then 2,2-dimethyl butane, and then 3-methyl pentane. Moving further with the cyclic, so we are done with the straight chain structure and branch chain structure. We have cyclic structure as well. In cyclic structure, as you can see, there's cyclic saturated and cyclic unsaturated. To understand saturated and unsaturated, we'll move to the next slide for that. But before that, please understand that what is cyclic. So as you can see that here we doesn't have any straight chain or any branch chain, but here we have a cyclic structures, okay, of the hexane. Here, this is the example of hexane only. Moving further with the hydrocarbons. So hydrocarbon is further subdivided into saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons is more further subdivided into alkane, that is CnH2n plus 2. This is the formula. And alkenes, alkynes and aromatic. Moving further with the differentiation or understanding that what are saturated and what are unsaturated. So saturated hydrocarbons are the single bond between two carbon atoms. Between carbon atoms, we should say that, not two, but yes, more than two, but there is a single bond between them. That is, you can just see the example. And alkane is the further division of the saturated. So the formula you can see here, again, that CnH2n plus 2. If we talk about the unsaturated, so here we have double bond and triple bond also. You can just see the examples of double bond and triple bond, that double bond is this and triple bond is just looking like that. Okay, alkenes and alkynes. In the alkenes we have double bond and in alkynes we have triple bond. So CnH2n and CnH2n minus 2. Further moving with the saturated hydrocarbon, that is, as alkanes is a subdivision of that. So general formula is CnH2n plus 2 and n is equal to number of carbon atoms. In this, the carbon atoms are connected by a single bond. As told earlier, that there is just single bond present. So here, methane, that is n is equal to 1, CH4, and ethane, that is n is equal to 2. By mistake, there is 1 written, so please correct it, students. C2H6, and then we have propane, that is n is equal to 3, C3H8. Yes. Okay, so moving further with the unsaturated hydrocarbons. In this, as alkenes is a subdivision, alkenes and alkynes. So the general formula is CnH2n for alkenes. N is equal to number of carbon atoms. Ethene, that is C2H4. Then we have propane, that is C3H6. Then the butane, that is C4H8. So here we can see that there is double bond present. Then moving further, as electron dot structure. If you are able to understand electron dot structure, it is easy for you to make these branched chain structure or the straight chain structures. Moving further with the unsaturated carbon compound. So here it is the electron dot structure of ethene. That is the double bond, as you can see in alkenes. Moving further with the homologous series. So as in homologous series, there is same general formula, similar chemical characteristics, but different physical properties. So as please note down, the molecular formula that we are going to study is CH2. Okay, so what are the physical properties? What are the changes in the physical properties? Why are they different? So yes, they are different because as the molecular mass of the elements increase, so there is increase there is change in the melting point, boiling point and density as well. So if I say that identical chemical properties due to this same functional group, abhi humne functional group ki baat kari, that is CH2. So yes, that's why here we can say that the similar chemical properties and different physical properties. Characteristics of homologous series. So as members of given a homologous series have the same functional group, that is CH2. So in methane we have CH4, ethane we have C2H6, propane we have C3H8, And then we have the butane in the same manner. So this is your complete chapter, and I hope this is clear to you. And if there is any doubt, please comment in the comment box. Learners, please subscribe to the channel, like and share the video. Stay home, stay safe, keep learning. Thank you, learners.